Okay, ladies, I'm going to do a very quick lesson on something called simplifying radical expressions. All right, and this is the foundation for it. Just take a look at this concept right here. The square root of 2 times the square root of 2 is equal to 4. That's equal to the square root of 4. And the square root of 4 is just plain old 2. So we can kind of get there a little bit more quickly if you just look at this and say, well, if these two are the same, the square root of 2 times the square root of 2, I'm just going to get the answer plain old 2. So let's look at another example of those. The square root of 7 times the square root of 7 is the same thing as the square root of 49. The square root of 49 is 7. So we can get there, again, a little bit faster. If we recognize that if these two square roots are the same, the square root of 7 times the square root of the same thing, then you're just going to get plain old 7. And that works for any positive number, as long as the number under the radical is positive. So if I say the square root of 23 times the square root of 23, I don't need to do a lot of work to get that. I can just say, well, if I multiply the square root of 23 times the square root of 23, I'm going to get 23. This is going to work for any value. I'll stick an A in here to represent any number. You multiply times the same square root. If these are the same, then you're just going to get that number out. This only works when the number's positive, but you don't have to worry about anything. We're only going to do positive numbers this year. So this is the basic concept that we're going to use to do what's called simplifying radicals. And I'll show you a couple of examples. I have about 8 examples to work through. So the first one is the square root of 12. Now, you know that you don't know what the square root of 12 is. We know the square root of 9 is 3. And we know the square root of 16 is 4. So the square root of 12 is going to be between 3 and 4, 3 point something. But instead of doing this as estimating, we're just going to write it in a different form. And we're going to start by doing a factor tree, the same factor tree that we did in our last unit. Break it down to its prime factors, okay? And then we're going to go over here and we're going to recognize that the square root of 12 is the same thing as the square root of 2, that's this one, and the square root of another 2, that's this one, and the square root of 3. So these 3 factors become the 3 factors in our square root right here. All right? The second thing is we're going to use that little concept, that little idea that I just showed you up here at the top. This idea that if you've got a pair of square roots that are the same, you can get rid of the square root altogether. The square root of 2 times the square root of 2 is plain old 2 without a square root on it. You can check this on your calculator. Type in the square root of 2 times the square root of 2, and you'll see that you get a plain 2 out of it. So this is called simplifying. We also want to note that we didn't use this one. It didn't have a pair, so it gets written down at the end. And this is considered a simplified form of the square root of 12. It's really pretty simple to do, but let me get through a handful of examples and you'll see that it's not very hard. You can use your calculator to do 2 things. You can use your calculator to help you make your factor tree in case you're not 100% comfortable with making a factor tree. This one's a pretty easy one, a 2, and then a 9, and the 9 breaks down to 3 times 3. But if you need your calculator, go ahead and use that. Then you're going to write these down as individual square roots. Each of the things at the bottom of the factor tree comes right here as square roots. And then we're going to look and see if they have any pairs. All right? This time, I have a square root of 3 times the square root of 3. And those 2 square roots, the square root of 3 times the square root of 3, become a plain old 3 with no square root on them. Look and see what was left over. This time we had the square root of 2 left over, and that's going to go right here. And that's our answer. So the first way you can use your calculator is to help you make the factor tree. And the second way you can use it, if you want to, you can take your calculator and you can type in the square root of 18 and see what the calculator says. And then you can type in the calculator the answer you got, 3 times the square root of 2, and these 2 things should be the same. I don't want to focus too much on the calculator part of it right now. We'll talk about that some more in class on Tuesday. I'm more interested in making sure that you can get from this to this. Okay? I haven't given you any that are really big. Sometimes, it's super, super easy. Square root of 15. If we make a factor tree for 15, we get a 3 and a 5. Okay? Well, there is no pair that's the same, and you get a 3 and a 5. You need a pair of things that are the same in order to make this work. So basically, you can't do anything. It cannot be simplified. And that is something that you need to recognize when you can't simplify it. You need to know when to stop. All right, so that's actually an easy problem because you can't do anything to it. Just leave it alone. Okay? All right, square root of 48, our next example. I'm going to break this 48 down. Remember, with factor trees, it does not matter what you start with. Just make sure that it's true. I look at this and I happen to see 6 times 8, but you could have started with 2 times 24 or anything. Just make sure you take the factor tree all the way down to its prime factors. And I would like to remind you that I think it's a good idea for you to carry everything down to the bottom of your factor tree so that nothing gets lost up in the branches. Oh, whoops, I changed it to 2. Let me fix that. That's a 3, not a 2. All right. Also, once you get all these factors at the bottom of this, put them in order when you put them back up here. Put all the 2's first and all the 3's second. So I've got 1, 2, 3, 4 2's. So I'm going to put all my square roots of 2 first, and then my 1 square root of 3 at the end. Okay? These came from right here. I'm now going to look for pairs. I have a pair here, and I have another pair here. And each one of those pairs is going to become a plain old 2. Square root of 2 times the square root of 2 is 2. Each of those comes out of the square root. And then I'm left at the end with that square root of 3 because it didn't have a pair. If you happen to get 2 things out, like we did right here, we got both of these out, I'm going to put them back together at the end, and our final answer will be 4 times the square root of 3. This number is kind of big, but it's a pretty easy number to work with, square root of 200. But again, feel free to use your calculator. Because it ends with 100, I know that this is just 2 times 100, and that breaks it down pretty quickly. Your 100 can be 2 times 50 or 4 times 25, whatever you want to work with. I guess I'll do 2 times 50, and then 50 is 2 times 25, and then 25 is 5 times 5. Now, if your factor tree looks like this is okay, but I've just had a lot of students who lose one of these numbers up here in their factor tree if they're not careful. So I'm a big fan, like I've said a couple of times, of bringing those factors all the way down to the bottom of my factor tree. All right, I'm going to put these in order. I've got 3 square roots of 2, and 2 square roots of 5, like this. I'm looking for pairs. I have a pair here, and I have a pair here. Those come outside of the radical now. So I have a 2 that comes out, and I have a 5 that comes out. This one didn't have a partner, so it stays inside. Okay? And the last thing you're going to do is if you took out more than one thing, put those together, and there's your final answer. It's really not very difficult. You just have to keep up with all your numbers in your factor tree. All right? Just a couple more. All right, the square root of 54. 54 is 6 times 9. Got that down to about 5 factors. I'm going to write them in order. Okay, and this time when I go to look for my pair, I'm going to do it from the back side, it doesn't matter. I've got a pair of square roots of 3 right there. That's going to come outside like this. And I'm left with 2 things that don't have a pair. I have a square root of 2 times the square root of 3. Those are going to have to stay in the radical. Both of them are going to go back in the radical. This square root, another name for this square root is called a radical. And then at the end of this one, I'm going to multiply those 2 back together and turn them into a 6. So what we're basically trying to do is figure out what can come out and what has to stay in. Now, my last 2 examples are very quick. I just want to remind you to pay attention. If you come across something that's a nice, perfect square, this is one that you're already supposed to know. You don't have to do a factor tree for that. You're supposed to know the square root of 121. The square root of 121 is 11, and you're done. The factor tree will work, but this is faster. And the last thing I want to remind you about is that if you can't always pull something out of the radical. If you do a factor tree for 21, you get 3 times 7. There's no pair. There's no pair of square roots here. So since nothing can come out, there's nothing you can do to it, and it cannot be simplified.
All right, 8 quick examples. I hope you find this pretty easy. You have a worksheet with 20 or 25 problems on it. Come and see me on Monday if you have any particular problems with it.